ISF, Department of Electronics and Communication Engineering, School of Engineering and Sciences, MIT ADT University. I extend a warm welcome to all the respected faculty member and dear student present here today. It's my privilege to welcome our esteemed guest speaker, Mr. Dinesh Panikar, an accomplished alumni of our ECE department and an embedded software engineer currently associated with Contech in Germany. Sir holds a master's in electrical engineering in and embedded system from Hochschule Ravensburg, Weingarten, Germany. He has strong expertise in embedded Linux, C, C++, and RTOS, and has worked with Signify on advanced embedded solution using Yocto and secure IT systems. He also has industry exposure through e-station in EV technology and is currently contributing to x86 based embedded system and hypervisor performance at Contact. Additionally, he has hands-on experience with free RTOS and Raspberry Pi system-based systems. So, we are truly grateful to have you with us. I would also like to extend my sincere regard for our respected program head of ECO department, Professor Dr. Sachin Takle sir, for his constant support and encouragement. A special mention to our faculty coordinator, Professor Rageshri Bakre ma'am and Professor Amit Patil sir for organizing this session. Before we begin the session, I would like to invite Professor Dr. Sachin Takle sir to share a few words. Sir, please.
Yes, thank you, Astha. At first, I would like to welcome Mr. Dinesh Panikar. I remember when he was in our college, uh, he has shown a keen interest in the hardware, and the same, I guess, the same interest he carried out during his career also. So, welcome, Dinesh, as an alumni. And my dear student, the appropriate topic has been chosen by our ISF, that embedded Linux. Hmm? And from ECE to embedded Linux, how we can get industry ready. Now, what do you mean by industry ready? The embedded Linux or embedded systems, you are aware that it is a system which is designed to perform a specific job within the given constraints. So more technical details Dinesh will speak, but I'll just speak about the importance of this topic. So there are growing demands in few industry sectors like automotive sectors, then IoT, then in semiconductor companies also there is a requirement of this kind of Linux-based boards. So uh, Dinesh, I would just like to tell you that we have established Center of Excellence in Semiconductor Technology in previous month itself, and we will be carrying out the research work in the same domain, continuing rather. Means few of our students are already working in this domain, so we may require your support in that regard also. So, students, now you are listening to us. Now it's time to listen to your peer, means former peer, your alumni. Now he has passed through the same ecosystem and now he is in market. He is aware about what are the current things going on and how exactly students, means you, should acquire the knowledge, acquire the required skills related to this particular domain. So I'll not take much of your time. I once again welcome Dinesh and I request him to continue with the session. Okay, that's it
Th-
from my side. Yes, Dinesh.
Thank you so much, sir, for your motivating and insightful words. Now, I would like to invite Mr. Dinesh Panikar, sir, to begin the session. Today's session title From ECE to Embedded Linux, a practical roadmap for getting industry ready. It's a great opportunity to practical insight and explore career path in embedded system. I encourage all the participants to actively engage. Student may ask question in the chat box during the sessions and can also unmute themselves to ask question at the end. Thank you and have a great learning experience ahead. So please continue from ahead.
Okay. Uh, Hello everyone. I'll just start sharing my screen. Uh, yeah. Yeah. Is it visible? Uh, can you guys see my screen?
Yes, sir.
Yes, it's
Okay.
visible.
Okay. So, good afternoon, everyone. I believe it's 5 p.m. or something in India. So, yeah, but I'm going to share with you a practical roadmap as to how could you shift from your ECE degree to something in embedded Linux. So yeah, let's get this started. I seriously wish someone would have given me this same guidance when I was in my bachelor's, and right now you're in the same place as I was 5 years ago. So yeah, okay, let's get started with this. So a bit about me. I have graduated from this university in 2022, and straight after that, I joined Signify as an embedded software engineer. And in Signify, that was the first time I heard of the word Yocto. Yocto, then C++, Zephyr RTOS and stuff. Uh, these were completely new to me. But the peers who I had in Signify and also my seniors, they were really cool with teaching me this stuff, and that's the reason I know that this is one of the industry trends going on right now. And I spent 2 years over there, and I was primarily responsible for the wireless area controller team. It's also called as the WAC team. So it's basically a device made out of Raspberry Pi, and it's used to control up to 200 lighting fixtures, 200 N sensor nodes actually, and it's a very advanced thing. So yeah. After that, I decided to pursue a master's in Germany. I'm currently pursuing that in electrical, like my master's is in electrical engineering and embedded Linux from Hochschule Ravensburg Weingarten. I'm currently situated in Ravensburg in Germany, and during my time of my master's in 2025, I was also responsible for being a Hilfswissenschaftler, or HIWI, as they call it in German, which basically overlooks for the embedded computing lab. And we teach students how exactly FreeRTOS and embedded Linux would run parallelly on a robotic system. And I was responsible for making the Yocto BSP image for that. And I was employed by the university for a year. And then after in the entire year of 2025, and then after that in 2026, from January onwards, I joined Congatech. Congatech is a small firm based out of Deggendorf in Germany. They mostly specialize in hypervisor stuff into both x86 and ARM. Out here, I'm mostly responsible for UEFI firmware development and hypervisor testing. Also a bit into QNX RTOS, like how exactly the QNX RTOS builds are configured and managed. So yeah, that's about me. So, what is embedded Linux? As the professor Takle actually said to you guys, that embedded Linux is basically Linux for resource constrained systems. So out here, I'm not sure if I'm visible. Out here, I have Raspberry Pi in my hand. You would basically build Linux for systems like these. Okay, what do I mean by resource constraint now? Resource constraint is basically systems which have a limited RAM, limited flash. Okay, this thing has a 2 GB RAM and a flash of about uh, this thing has a probably around 4 GB of flash or something, depending on what you have on the SD card. But nevertheless, the Linux which would be running for systems running Raspberry Pi or BeagleBone Black or some of your custom boards, that would be called as embedded Linux. And what really makes it embedded? That's the one question many people might be thinking, is because you have Linux really brought down to a very limited system. For example, in this Raspberry Pi, if I connect any peripheral, I connect, let's say a GSM sensor or something like that. I just want to have all the modules responsible for communicating with any IoT devices or something, or with in GSM with any kind of communication protocol or something like that. So I would want just the Linux required for that. And this is what I mean by a custom kernel config. Custom kernel config is basically a thing which you you want to basically have the bare minimum stuff inside of this, because this would be used as a mass product and would be always be updated and stuff. For this reason, we would be having a custom kernel config, also a minimal user space. Whenever people think about Linux, or they usually think about Ubuntu, right? In Ubuntu, you have the entire GUI, you have a lot of things going on there, which is not required, to be honest, for an embedded system. But when you go for like an embedded uh, uh, target, like a Raspberry Pi or a BeagleBone Black, you would just have a command line interface. That's all, nothing else. And now in that command line interface, you would need to look at all of your network drivers, all of your PCI stuff and different things. So that's one thing. And also it should be real time. And what I mean by real time is, for example, if I'm having an arm robot, whatever commands I'm sending, like for example, if it has to pick an object, it should know where the object is situated, where it's located, where the arm should pick it up and stuff. So that's what I mean by real time, and also should be cross-compiled. So where is this used? Mostly you could see this being used in the automotive systems, in industrial automation, in IoT, where I've worked in, and also in medical devices. Uh, you would use this system in every place you see around you, whatever application you have, which is not a PC-based application. Uh, Even smart TVs actually are built out of embedded Linux, if people didn't knew about that. Smart TV is basically into like an Android OS, and it's also not like I'm talking about the smart TVs which cost less, like around 10,000 rupees or something. Those TVs are basically, I would say, an embedded Linux. That's the best example for showing someone what's embedded Linux. And why it matters, it's because it's open source. Um, whatever points I've written here, like no licensing fees and like industry standard and highly scalable, is it's because it's open source. And where does the embedded Linux fit? Um, so when you code for your microcontrollers, you have three types of it. You have something as an Arduino Uno, which is an 8-bit microcontroller, and you would just be coding this in bare metal C. Then you would go with like an STM32. This is a microcontroller which could run an RTOS. It could run your IoT tasks and stuff. So I would call this an RTOS-based system. Then you would eventually switch to an embedded Linux system, which is your Raspberry Pi. And where would these be used? Your Arduino Nano type systems would basically be used for like sensor nodes. That's the best example of a sensor node, but you could also use sensor node as your STM32, for example, if you want real time in that. But yeah, if you want like really cost effective stuff, you would go with something like an 8-bit microcontroller or something like that. But if you want to control these different sensor nodes parallelly or concurrently, how would you do that? You would do this with the help of a Raspberry Pi or a BeagleBone Black or anything which has at least, I should say, 2 GB of RAM or something like, or at least 2 GB of memory, and would basically be really uh, and would have a processor like this BCM2350, which is I think so inside of this. And it would also have a file system. It would have an entire TCP IP stack, and it's really complex. So the industry landscape, as I said previously, automotive is always hiring. You should in India, if you see most of the companies which are from Germany, mostly automotive, like you have Continental, you have Valeo, they always look for students. So I suggest you should always like you should first see for some like automotive openings. Even KPIT is really good. Like I had a friend who worked in KPIT for 4 years and he's right now in Germany. So I mean it's a really good place to start from. Then you have IoT, where I worked in Signify. And in Signify, you also had a plan where you could like spend at least 5 years. If you spend 5 years in the company, you could eventually switch to Netherlands. Signify was headquartered there, so yeah, it gives you opportunities to go around the world and also explore stuff. And in my current role in Quanga Tech, I work for the industrial automation systems. So hypervisors, in general, what it means is you could run multiple operating systems on your chip, on your bare metal chip. So we run about like almost 24 operating systems or like an RTOS and a GTOS parallelly inside of a chip. And we supply these to a company called Contron Europe, and then they make it for different automation companies. They make the end boards, the end development boards for like Beckhoff. Beckhoff is one of the biggest ones in Germany. Then you have ABB and then Rockwell Automation. That's the reason I included this industrial stuff over here. And then you have the bigger names, like for networking, you have Qualcomm, for consumer electronics, you have Samsung, and then for medical devices. Um, for medical devices, you would also go on to resource constrained systems, probably into low power wireless and stuff. So that's also a really interesting domain to work on. So yeah, all in all, embedded Linux is used everywhere. Now, let me come back to uh, bridging your ECE subjects to the industry. So now, as far as I know, this was I believe the course curriculum is kind of the same what I did back then. So you have SPOS. I think so. This was taught by Professor Tafle. This is mainly into Linux system programming, and this teaches you a lot on Linux internals. It's one of the most beautiful subjects to ever enter into your embedded Linux world. And why is that so? It's because this teaches you about operating system concepts. It teaches you about process scheduling, about what is a process, what is a thread and stuff. And this is a one of the subjects you should know really nicely to start with embedded Linux. And then you would go on with like embedded processors. Embedded processors teaches you about ARM. What is exactly the ARM design philosophy? ARM has a very, I should say, broad design philosophy. You have it for both your STM32 as well as your Raspberry Pi. Raspberry Pi is basically ARC64, and this is like an ARC32, I would say, but this doesn't have an architecture like for coding for Linux. This is very RTOS oriented. So yeah, I mean, embedded processors, you mainly learn how to program this board, and this teaches you a lot as a basic subject for learning Raspberry Pi stuff. So yeah, and also digital electronics and computer organization. These two subjects, they form the basics of embedded. So if you know your digital electronics and your computer organization very nicely, you can learn about a concept called as device trees. And device trees is basically a concept in Linux. Whenever you boot your board up, it would look at all of the hardware configurations you have. So, for example, if I have this Raspberry Pi, it runs on a BCM 2350, I believe. It would look at those board specifications and also whatever devices you have attached to it. For example, if you have a sensors or something like that, you could add a device tree for that, and then it would understand that this is a part of the board and stuff. So digital electronics would give you, and computer organization would give you a good basics on what exactly the basics of what exactly a device tree would be, and also which microcontroller to choose for your task. For example, you wouldn't use like a Raspberry Pi for like temperature sensing or something. You would use an Arduino for that because a temperature sensor and is basically a very simple task. You just need to monitor and log. So this is where you would apply your digital electronic skills and computer organization. That's what I believe. And your data structures. Now, in the interview, in whatever embedded software interviews you're giving, the first two rounds would be basically based out of data structures. It will be based out of data structures. It will be also probably be based out of embedded processors and SPOS, but data structures is one of the most important subjects you should master. And which concepts you should master for embedded Linux? Linked lists. Linked lists is the basis for Linux kernel programming, is the basis for everything you have in Linux. Okay? Uh, Even when your PC starts up, when your PC boots up, you have an entire sequence of events going on in that. And how it does this? It does this with the help of linked lists. Linked list is a very important concept you guys should learn. You should also learn how to exactly optimize your code, because in the end, your code would go into something like this. And if it what do you call, corrupts the memory, or if it increases the, like, you have a limited RAM on, like, your STM32 or something like that. How would you exactly arrange your binaries to, like, to get it optimized into that memories region is very important. So data structures is also important. Computer networks as well, because computer networks would teach you a lot on the IoT stuff. And not only that, in some of the interviews I've seen, which I've given, they mostly ask you about the CAN data formats, the CAN frame structure, or the IPv6 frame structure, or the ZigBee frame structure. So yeah, I mean, computer networks is also a really important subject to learn from. Then, yeah, your embedded processors and microcontrollers are kind of the same, but I believe you should also learn RTOS. And I'll come to this later as to why you should learn RTOS, but RTOS is also an important concept to learn before you go into embedded Linux. So the roadmap, which is the most important skill for you guys? What do you think? Is it like, what do you call, uh, is it hardware, or is it programming? It's programming, to be honest. Hardware, you could, for example, if you want to know how how your processor works, uh, you could define it through, like through circuit diagrams and stuff. But how would you convert your circuit diagram to an actual code? C programming is very important. C programming, why do I say C? Is because people usually ask why not C++ or Python or Rust? Many people are shifting to Rust. Why not Rust? Well, to learn Rust, you should know something called as the ownership model, and for that you need to know C++. And the basis of C++ is C. If you know C, especially at the stage where you guys are in your second year and third year, it's very important. So some of the topics which you should know from C are basically pointers, memory management, data structures. These are the most important concepts you should know from C. Half of the embedded interviews are around pointers. How do you manage pointers? How do you manage data? How do you, like, uh, manage linked lists and stuff? This is very important. Then you have your Linux fundamentals. I suggest you guys to learn C through a Linux environment. Never learn C on Windows. This is one of the biggest mistakes I did in my second year, where I learned C through Windows in, I don't know, Borland C++, in the Borland environment or something. I don't remember that. It's like Turbo C or something like that. I learned C through that. And honestly, I feel like I should have learned it through Linux. Because if you learn C through Linux, you learn way more. You learn a lot of concepts. You learn about GCC, you learn about GDB and all that. And this is where cross compilation comes in. Cross compilation basically means, uh, let's say you're coding for, you want to code a binary for your STM32. This works on ARM, but you're coding on your x86 machine, right? How do you transfer your x86 binary to this STM32? There are a lot of steps going on in the middle of it, right? If you have a STM32 cube IDE, it wouldn't teach you that much. What you should do is just take your STM32 board, connect it to your Linux-based machine, and start coding it through the command line interface. This will teach you way more about cross-compiling, about what exactly options you need to enable to the compiler, um, what exactly the target you're trying to build and stuff. It's really important to know that. And this skill is when you learn it when you're in your bachelor's. This is the best time to learn, okay? So just go on with this. And then I would suggest you to go with Yocto, but never start with Yocto. I mean, the thing is, Yocto is a intermediate skill. Okay, you need to be very good with your RTOS concepts, with your OS concepts in general. So if you are very good with your systems programming and operating systems concepts, and in general, if you're good with that subject, you should then start with Yocto. Yocto is not a, I should say it's not a beginner oriented thing. It's more of an intermediate stuff. But what the roadmap I would suggest you is to go first with something called as build root and then Yocto, because then you would know what exactly, like, the end images, what exactly the images you need, what options you need to enable in the compiler and all that. So Build root is a good way to start with, and then Yocto, because Yocto is an intermediate skill. Then you have the communication protocols. Communication protocols is what you learn in your bachelor's, your computer networks. Everything is related to communication protocols. Every interview would ask you what is the I2C frame structure, what is the SPI frame structure. Knowing these two concepts, knowing these two protocols is very, very important. Even if you're aiming for automotive companies, you should know the CAN bus in and out. Okay, what exactly is the CAN bus? How do you program that for an STM32 application and stuff? It's very important. Then, depending on the company, if you're going for IoT and stuff, you would mostly be asked about IPv6, Zigbee. Um, there's also, I believe, Thread protocol, but mostly I've seen companies asking about IPv6 and Thread and Zigbee, not Thread. So you should know about that, and also the Bluetooth. What exactly is a Bluetooth protocol? Um, to be honest, if you want to learn for an interview, you should look at the company first and then see what kind of stuff they're working on, and then prepare the communication protocols accordingly. Okay. And another suggestion I want to give you guys is to learn in private, but speak up in public. What I mean by that is you do your projects, but always post them on GitHub or GitLab. It helps you a lot. Post them on LinkedIn, what do you call, contribute to open source projects. They actually build your profile. Okay, if you do not have a GitHub portfolio, or you don't have a GitLab portfolio, it's a huge disadvantage for you in this economy. You should know GitLab and GitHub stuff. Also, you should know about how exactly would you go with CI/CD, continuous integration, continuous development. But CI/CD is a secondary skill. I wouldn't bombard you with that. But just know how to post your project or stuff on GitHub. Now, as I said to you, RTOS is a very important concept to learn first before you head into embedded Linux. And why is this so? If you think about RTOS, RTOS teaches you what is scheduling. RTOS teaches you what is how to run tasks concurrently. It teaches you how to run, um, for example, if you have an LED, you want to blink that LED with two different timings, like a 500 millisecond timing and a 1 second timing. How do you blink that LED like concurrently with that? You would use a free RTOS for this. You could use a free RTOS in your STM32 or ESP or whatever boards you have, but do use and understand free RTOS. This is the first step you should know before you head into embedded Linux. It teaches you a lot about mutex, semaphores, ownerships, and stuff. And people who want to go into, like, later on into Rust development, knowing about ownership is a very important skill, and RTOS teaches you that. Also, if you look at the mapping, the tasks in RTOS are basically your Linux thread processes, your ISRs or the interrupt service routines, your interrupt handlers, your HAL is your device drivers and stuff, and so on. You should know about RTOS first before you head into embedded Linux. That's one advice I would give you guys. Now, some project ideas. This is very important. You should know how to do LED control on a Raspberry Pi using C. Never use Python. Most of the tutorials on the internet will teach you how to interface a sensor with Raspberry Pi using Python, which I honestly feel it just removes the joy of knowing what exactly is going on inside of the system, right? What I suggest to you is to search for this channel called Johannes for GNU or Linux. His name is Johannes. Uh, he actually has a course on Linux device driver programming, and that teaches you from scratch how do you program on C in a Raspberry Pi based system. It teaches you a lot. It teaches you about make files. It teaches you about cross compilation, everything. So do learn this stuff from Johannes for GNU Linux, and yeah, that's one way to start with. And also implement a project. For example, I just added this temperature logger with an I2C sensor. So I just added BMP 280. The reason for adding this particular sensor is because um, this has a very good documentation, but very rarely people actually implemented this with Raspberry Pi. They usually interface this with an STM32 and they call it a day. But honestly, if you implement this with Raspberry Pi and you have the system programming concepts within you, you would be at a much better position than most of your peers. And then after that, a simple shell in C that you could do it through anything on Linux. And FreeRTOS Blinky, as I told you, to blink an LED parallelly with different what do you call it, different time differences with time delays, like a 500 millisecond one and then a 1 second one. That would teach you a lot. Then I would tell you to go, if you start with Yocto, do start creating a Yocto image for a BeagleBone Lab. This would teach you from scratch how do you develop a Yocto image for a resource constraint system. And then learn about QEMU. Over here, I've written a Linux character device driver for RPi or QEMU. What is QEMU? QEMU is basically an emulator. This would teach you how to boot up your custom operating system, what you've developed in Yocto. And by the way, what Yocto does is not Yocto is not a Linux distribution, by the way. It develops Linux for both like these. If you want to test your Yocto image and you don't have a Raspberry Pi with you, you could use QEMU. QEMU would help you to simulate your Raspberry Pi and would help you to see how exactly how the board boots up and stuff. So do learn about that. And then um, I would suggest you to go to my LinkedIn and have a look at this project, CAN Bus Monitor and Logger. This project I developed on top of a tutorial series by a guy named Sean Heimel. He is a really, I should say, he's a really good teacher for teaching you embedded system stuff. He has a channel called DigiKey, and I would suggest you to go through the DigiKey tutorials for Zephyr RTOS if anyone's interested to go for that. And this project is built on top of that. Like um, he built a temperature monitoring system through one sensor and an LCD on Zephyr RTOS. What I did is I just basically built a CAN monitor and logger through the CAN. There's a CAN sensor called TGA 1050, and I interface that with ESP32 and display and just showed the CAN frames. I also had a socket CAN to send the CAN frames from your PC to the ESP32, and your ESP32 then would show, okay, this is the CAN frames I've received. What to do ahead, it depends on you. But this CAN bus monitor and logger is a really good starting. It's also a really good intermediate or advanced project to show on your resume. Then, if you want to start with embedded Linux as well, you should also choose a niche. And the niche I've kept over here is computer vision. Face mask detection, people usually run that on your PC, right? You have a face mask detection, it looks at your face, and yeah, you're done. I would suggest you to run that on a Raspberry Pi. And first use OpenCV and then use your own algorithm on, like, understand how the OpenCV algorithm detects your face and then build your own classifier algorithm or your own detection algorithm and see how exactly that runs on an RPi 4B plus a Pi camera. This would teach you both computer vision as well as embedded Linux. And to be honest, in today's world of AI, knowing computer vision is a very important skill. That's the reason I included this as a part of the face mask detection. But yeah, now I'll go on to a real world project which I developed in Signify, which has given me immense learning. So in the year of 2023, I was involved in this one project called as the Area Hub. Now, I was mostly doing Yocto here, but this was the first time I was ever exposed to Zephyr RTOS over here in this one project. And this one project taught me how to do an actual embedded project within a 6-month time frame, right from concept to the end product development or deployment. Um, I was basically responsible for maintaining the secure boot and the OTA part inside of this product. So this is basically an Ethernet gateway. This has 8 ports over here, and this can connect up to 80 devices. It says here 8 wavelengths cat local areas. What it basically means, it can connect up to 80 to 90 devices using Ethernet and CAN. And the reason we use CAN was because some of the power converters had CAN in them, and that's the reason we had both Ethernet and CAN. So this project taught me a lot on what exactly embedded development is. Also, the protocol stack was mainly into CAN bus communication and Ethernet, which was a very demanding skill. I also learned a bit about cybersecurity in this. There's something called as static analysis and dynamic analysis. So when you write code in C, especially with linked lists, you have something called as there's some functions called malloc and calloc, and then you have free, right? Now, now the problem is when you code for C, sometimes you forget to free some memory, and then you would go into something called as a memory fault, or you basically used up most of your memory, and that would be catastrophic for your device because your device would basically be hanged or would always produce a memory fault or something like that. So for handling this, and also you could also pose a cybersecurity threat because any person could look at you could basically hack your end device with the help of a binary, okay? And basically they could corrupt your memory, and then your device is unresponsive, and then you would be basically sitting and scratching your hair and just debugging why this is happening and stuff. For this reason, there's something called static analysis and as well as open source audit. What it does is that static analysis looks at all of the part of the code which is memory unsafe, and then it tells you which part of the code is memory unsafe, and then you have to rewrite that, and then you're completely fine. Open source audit. There's a tool called Black Duck, which looks at all of the vulnerable open source libraries which you've been using in your Zephyr RTOS stack. And this also gave me an entire look into how cybersecurity was important. And doing this actually gave me a Super Lumen award in early March of 2023. So the key takeaway here is everything I learned from this degree in electronics and communication was used over here. Okay, so this is an actual company project which I did in the entire year of 2023, and it gave me an actual um, end user project. Now, shifting ahead, how do you land your first embedded role? As I told you previously, you should learn in private, but you should show your projects in public. What I mean by that is always build a GitHub portfolio. GitHub is one of the most important ways you could upskill yourself, you could show yourself, you could tell everyone around the world, okay, this is what I did. I want to do this. I'm really interested. Tell me more. You know, you can also go to some open source projects. For example, in Zephyr, you have a lot of modules which require open source contribution. You could go to one of them and then start contributing. Building a GitHub is very important. And then you should tailor your resume. I'm not an expert on resume building, but I could just say that just keep it one page because many of the recruiters don't have it. They just scan your resume for 5 minutes and then they go. They don't have time for just reading what you have written in 2 pages or 3 pages or something like that. So just keep it one page and just keep it completely concise, and then just keep it generic. And when you prepare for the interviews, as I said to you previously, data structures, operating systems, computer networks, these are some of the most important topics you'll be having for your interviews. And this is the time, your second year and your third year is your time when you actually can work on this. So don't waste your time. Work on C, work on data structures and algorithms, work on building real projects. And this is how you actually prepare for the interviews. Now, where do you apply? In India, most of the companies they post their jobs on LinkedIn. LinkedIn is a great platform for applying and stuff. But then there are also other platforms, for example, Naukri.com. Then you have some of the pages, some of the career pages in like KPIT, Infineon, TI, and stuff. So this is very important. And I'm saying this after giving interviews to at least 4 or 5 major companies. One of them being Texas Instruments, which I had given in mid of 2024. Um, just because the managerial round didn't go good, that's the reason I wasn't selected. But then after that, I got an admit from Germany, and I went to do my master's. So yeah, the key point is, if you want to land your first embedded role, you need to take your second year and third year seriously and follow this learning path. This learning path is from my own. So yeah. Next is your resources. There's one resource which I've kept it on the first. Oh, sorry, which I've kept it on the first part, your first book basically, which you guys should buy right now, is Learn C the Hard Way. Learn C the Hard Way is basically a 300-page book which teaches you how to program in C on a Linux environment. It teaches you everything what I said. It teaches you the basics. It starts from basics of C to data structures to operating system concepts, and it ends at building an actual server, an embedded server. And it teaches you a lot. This book is one of the most important books I feel has brought me the skill set I require. Then you would go with the classic book, The C Programming Language by Dennis Ritchie. The thing is, I wouldn't suggest you guys to go with this book first because this is a very algorithms oriented stuff. So yeah, I mean, if anyone who has completed Learn C the hard way should go with this. But doing this, the first resource, which is Learn C the hard way, it teaches you a lot. Okay, so just do that. Then you have a book by I believe his name is uh, Beginning Linux Programming. I'm not sure of the author's name, but it's a red colored book on Amazon. Um, if you search for that, you'll get it. But do learn this book because this book teaches you Linux programming in C. Everything is implemented in C over there. It teaches you about makefiles. It teaches you about cross compiling. It teaches you about process threads, IPC, everything. This book is one of the main books you should be these two books, the beginning Linux programming and Learn C the hard way, are the two main things you should always have. Then once you do them, you could then go with Linux kernel development. And there's a very famous book called Learn Linux. There's a very famous book called Linux Kernel Development by Robert Love. And this is the book I'm currently reading, to be honest, because kernel development is something which I'm looking at right now for my master thesis. And I would need to learn a bit of the Linux kernel side, so that's the reason I'm reading this. But yeah, if anyone's interested to know exactly how to go with Linux kernel development, this is a really good book. But yeah, as I said to you, first make your C programming really good, make your Linux kernels really good, your data structures and stuff, and then move forward with what you want to do. Then on Udemy, there's this channel called Fastbit. Fastbit has some really good courses on Udemy for learning FreeRTOS as well as embedded Linux. But mainly their FreeRTOS course, I really liked it. It teaches you everything on FreeRTOS, so go with that. And also on NPTEL, um, in my second year of engineering, actually, um, I had done this course called Introduction to Embedded Systems by I think so his name was Dhananjay Gadre, that Professor Dhananjay Gadre. He has a course on Introduction to Embedded Systems for MSP 430 microcontroller. It's basically a TI-based microcontroller, and a 16-bit one, which is used for extremely low power programming. So this is also a really good resource to go with. And then you could go with some of the Linux Foundation talks. They're really interesting. So yeah, I mean, Bootlin is also good, but I would suggest you to go with the Linux Foundation talks. They go a lot on what do you expect from the industry. Then on online, I suggest you to join. If anyone's using Reddit right now, you should join these forums called r/embedded and r/kernel. They are really good forums to learn and explore and network. I've also ask some questions over here on r/embedded. So this is a very good platform to learn. And on YouTube, there are some people who are very good at teaching you stuff. One of them is Sean Heimer. I honestly feel I can't tell you how much indebted I am to that guy. He has an RTOS series in DigiKey, and the way he teaches RTOS is so interesting. Like any new person who doesn't know anything about what exactly real-time programming is or what an RTOS is and stuff should just go through his YouTube through his videos series. You will know everything about RTOS over here. Then you could go with like Jacob Sorber. Jacob Sorber is a guy who teaches you data structures and stuff, and also teaches you about hex dump and ops dump. Hex dump and ops dump are two very important binary tool uh, utilities which could help you to optimize your code. So, I mean, he's also really good. And if you are interested in security, in cybersecurity and stuff, go with a channel called Low Level Learning. He covers a lot on cybersecurity stuff. How do you go with memory safe programming and stuff? So yeah, this DigiKey YouTube channel, as I said about from Sean Heimel, is a really good place to start with in embedded systems. So yeah, this is one suggestion I could give you. And yeah, so the key takeaways from today's presentation is that where you are right now in ECE, it's the perfect foundation for you to get started in embedded Linux, to be very honest. This is a degree which would give you 70% of what you need, okay? It would give you the perfect base to start from. And I can't stress this more, but you should always master C first. Okay, no matter people tell you to do Python, JavaScript, or I don't know, Ruby on Rails or whatever, always go with C. C is the language of embedded systems, it's the language of logic. This would teach you everything. Like, um, I've seen people also implement machine learning algorithms on C. Okay, so if people say, I want to implement machine learning on Python, it's really good, it's really interesting. Well, C would be like, okay, hold my beer. I mean, C is the best language for learning how to develop logic and in general, anything. Then go with an RTOS. FreeRTOS is a good place to start with. Zephyr is a bit advanced for you guys. I would suggest you to go with FreeRTOS and then transition to embedded Linux. And always build projects. Always build projects, post them on GitHub, and this is your resume. Okay. Then, as I told you, learn the protocols. They come up in every interview, and yeah, and in today's time, in India especially, there are a lot of companies hiring for automotive and IoT all the time. Every time in my LinkedIn, I always see, uh, I see few job openings in Bangalore and Pune, Hyderabad for automotive. So do apply for them and do make really good projects for them, for your resume to get selected for that. So yeah, anyone, I'll be opening the forum to questions and discussions. If anyone has questions, in general on embedded systems, career paths, even studying abroad or getting started, I can go for that.
Hello.
Hello, yeah.
Yeah, I do have a question. How
Mhm.
important is the end-to-end system design when it comes to applying for job roles? Also, how can I land an internship when I have no prior experience of anything?
Okay, end-to-end system design. I'll go with that first. Um, so it depends. Like end-to-end system design is basically how you start from your concept to an end project, right? You should know what you like. For example, you should choose a niche. Um, as I told you, computer vision is one of the most important niches you can find in today's time and space. But you can go for anything. Like power electronics is also really huge. Power electronics, you have battery management systems. You have a lot of things. You also have smart gateways. Like what I was developing in Signify was into smart gateways. So if you have no prior experience in embedded, honestly choose a niche. That's the first thing I would suggest you, like any of these things, and then build a project on that. Build a a simple face detection algorithm on OpenCV and or build it yourself. Post that on GitHub. Post that on LinkedIn. Start approaching recruiters that I'm really interested in this in your company, and I really like doing this, and then go forward with that. That's what my first suggestion would be, to go for internships. And yeah, also don't look at the money. Yeah, I mean, many people would say, my internship is not paying, what to do. I would say your first internship, your first whatever you get, your portfolio or project or whatever, just don't expect money from there. Just do the things and gain the experience, and yeah.
Okay. I had another question. Like, what are
Mm-hmm.
some companies that I should look out for? Or like some companies, maybe like a list of the ones that I should keep them on my, like, just make sure I know what they are.
Mm-hmm. Um,
Like, what would those companies be?
okay. Um, you could go on, like, for example, as I mentioned, KPIT is a good starting place to go with. Um, like, I know they, for example, they have what do you call, a 2-year thing, like a 2-year bond thing. But like these, if anyone wants to go into automotive, this is a good starting place. I have many friends who are in Germany over here who have been in KPIT, in Bosch, and like KPIT, Bosch, Continental. These are the 3 companies which I would be looking for if I'm interested in automotive. You should read about what they do. There's something called as software-defined vehicle, and many companies are trying to achieve that. They're trying to go into that, and these companies, KPIT, Bosch, Continental, these are good starting places to go with. Always apply
I
for
heard a
them.
lot of them don't, I've actually heard a lot of them don't admit freshers, which is why I'm a little confused.
Hmm.
Right. So,
KPIT does that though. KPIT does that,
okay.
I believe. I believe KPIT, they do take in freshers. You can also go with any startups. For example, in Pune, in the area of Pimpri Chinchwad, you have a lot of startups there. You could approach them by going to there's this thing called as Electronics for You. I'm not sure if you know about that. There's a magazine called Electronics for You, and they usually
I
have
do
these
know about that.
expos. Yeah, you should go for the one of the expos. They usually present their products there. Go and approach them. Uh, there are a lot of startups which showcase their products in that expos. Just go and approach them.
Okay. Thank you.
Yeah, sure.
Hello.
Yeah.
So my question was related to study abroad. Actually, I was preparing for my master's in Germany. For that,
Mm-hmm.
I have completed my German A2 level and going with now I'm currently preparing B1.
Okay.
I have also started classes with IELTS, and I was looking for winter 27 intake. And also
Mm-hmm.
I'm doing an embedded courses. I want to do masters in embedded, so I was
Mm-hmm.
also doing my extra courses from embedded IoTs and as you said, Linux IoT, Linux embedded. So
Mm-hmm.
what more should I do to add a few things in my resume to get admission in the public university? And in which sector of electronics should I go for my master's, like in microelectronics or in embedded systems or semiconductor? Can you please suggest?
Okay. In Germany, firstly, you should know that there are 2 types of universities. One is a technical university, and then there's a Hochschule. I studied in a Hochschule, and the reason I took a Hochschule is because I want to go into application development. Like, I don't want to always like I don't want to I didn't want to pursue a PhD. Okay, it depends on you. If you want to pursue a PhD, you can aim for a technical university and stuff, and probably do like microelectronics or semiconductor stuff. But if you want to have a job after your master's, or if you want to go into application like into an application development, and yeah, you don't want to study further, you should go for a Hochschule. Hochschules are very practical in teaching you stuff. So that's one thing I would suggest you to go for. Secondly, improve your German. Like, I know you said A2 level and now you're studying B1 level, but to be honest, the job market in Germany is very competitive right now. You need to at least have a B2 level German for even an internship or
Yes,
or
I
work
was
students and stuff.
before before applying for the universities. I am going to
Hmm.
complete till my B2 level in India, and will
Okay.
be looking even in Germany then.
Yeah, and also improve your CGPA because if you have a CGPA above like 8.5 or around 9, you would be in a in a much better position than people who have less than 8.5. So yeah, I mean, always look out for this, your CGPA, your German, and yeah, as you're working on embedded, you should also parallelly do that. But this is like if you're coming through masters in Germany, uh, do think of what you want to do. Um, do think of the amount of time you're going to invest for masters, because in a TU, people take up to 4 years to complete their masters. Okay, it's a very rigorous program in a TU. In a Hochschule, people take up to 2 to 3 years, depending on their work student internships or their thesis timelines. And yeah, this is one tip I would suggest. Like, always look out, always know what you want to do. Like if you want to go, even if you want to do like microelectronics or VLSI stuff, there's a good market for that as well in Germany. Um, I would suggest you to uh, improve your improve your CGPA and also improve your German, and that's one thing I can tell. Yeah,
Thanks, sir.
Uh, sir,
yeah.
good evening, sir. I
Hmm.
really wanted to ask a question. Nowadays, a
Okay.
lot of companies are using FPGAs or ASICs to,
Hmm.
get the code into them. So, is it
Yeah.
relevant to when it comes to embedded systems part?
Yes. See, it depends on the end product they are making. For example,
Yeah,
I was recently giving an interview with Infineon, and they wanted a person who had an expertise on VHDL, C, and Rust. So, I mean, you need to the thing is, the reason I didn't mention the FPGA or the things
yeah,
which are into this is because in embedded, usually people would imagine embedded as a microcontroller or something like that.
true.
In FPGA, you need to know both. You need to know VHDL very nicely, at least VHDL or Verilog, any one of them. But
Yes.
to be honest, if you take this, if you're aiming for FPGA based companies, you should look at what products these companies develop, the end products. Okay, um, for like there are some for example, there's a company called Tech in Germany. They also have a branch in Pune, by the way. They develop custom SoCs for um for the for the HMI industry, like human machine interface, basically your automotive interfaces and stuff. So they develop SoCs for that, and they need programmers who know like VSDL, C, and stuff. So VSDL could also be like it depends on the end product what the companies want, right? So this is also a very good skill to add in your resume. VSDL, C, Verilog, and all that. So
Yeah,
yeah,
most.
it depends on the
Yes.
end product. So that's what I can say.
So they are mostly intertwined when it comes to these kind of applications.
Yes, yes,
And
they're
if
mostly intertwined.
And if suppose there are a lot of companies who not only aim at this but also aim at what you've told in your PPT, right?
Hmm.
So like how did you know what way did you want to choose in this sector? Like there are a lot of applications and a lot of topics which you can go through or
Hmm.
practice. How did you know you had to get in this particular sector? Not in
Okay.
embedded systems, but in the subsectors in it.
Um, okay. When I was starting out, especially when I was applying from college to different companies, um, I actually had three offers with me. One was from Signify, one was from Nissan. I think so. Renault Nissan. Yeah, that was the name. It was in Chennai, and then there was another company. I believe it's called Alpha Level or something in Pune. Yeah, I had offers from these three companies, and when I was preparing for the interviews for them, I prepared basically on the projects I did, on the skill sets I know, and also the interview questions were mostly on register manipulation, bit manipulation, and all that. Very basic. So the thing is, I didn't at the time when I was applying, I didn't know, okay, which domain I want to go to, and I didn't even have a proper guidance for this. For this reason, I chose to like chose to go for with whatever gave me the best offer at the time, and that was Signify, because Renault Nissan was in Chennai. It was like 3.5 LP or something. Uh, Alpha level was in Pune itself, but it was not exactly embedded. It was embedded and PLC stuff. But I knew I wanted to go into embedded. Like I didn't want to do PLC and all that. So I didn't go for that. And then Signify was the perfect choice because at the time they were offering really good, like 7 LPA, and also they were into embedded and IoT. So it depends. When you prepare for technical interviews, you should always know your basics very nicely. And where you guys are at right now in your second year, third year is when you actually build that.
Right. As a student, I am very, interested in every subject which is taught in this EC program. So it's very hard when it comes to choosing one field out of that.
Mhm. Um, uh, One suggestion I can give you on that is um, go to the lab or probably uh, take a microcontroller, just take an empty IDE and just start programming whatever you feel like. And when you see the result on that, if it gives you really a joy that, oh, this is my calling, this is what I want to do, um, then sure, go ahead with that. Or else, if you are interested in FPGA side, I would suggest you honestly to either borrow an FPGA or take you have this thing called as iSticks. I'm not sure that you might be knowing about them, but iSticks is from Xilinx. You get them really cheap on robu.in. Yeah, you can buy one of them and start just seeing how exactly in VHDL main thing is the timing constraints. How exactly your register whatever you're building, like a simple um, a simple D flip-flop or whatever you're building on that, just see how that translates to the actual hardware and whether that interests you or the C, like coding in C and then porting that to a microcontroller that interests you. So you should try this. You should try different things. You should also take a breadboard and build like or and build a really complex circuit. For example, um, there's this channel called Ben Eater on YouTube. He actually builds an 8-bit computer from scratch on a breadboard. So if you're interested in like building stuff on breadboard and seeing how that is arranged on that, I mean, sure, go ahead with that and see whether that actually is your what do you call your calling. So if I was in your place, I would try these stuffs, but at the same time, keep your basics really clear. Keep learning, keep um, sharpening your basics. Also, I would suggest you if you could also use probably AI for learning the stuff. For example, Claude is a really good tool for teaching you what this code does and stuff. So, for example, if anyone's interested in Linux kernel programming, which I am actually learning right now, what I would do is I would just, for example, if I'm seeing a scheduler code, I would just paste a part of the function which I'm not able to understand to Claude, and then ask Claude as to what to do in that, and it'll teach you really nicely. Claude could be probably your secondary virtual professor types, you know. So use AI for learning that, and that's how you actually see your niche. Um, Initially in ECE, when I started, I was really interested. I honestly, when I started in ECE, my first year, I was in my first semester, I wasn't interested in electronics at all. Okay, it just later on in second semester, third semester, when we started doing electrical circuit analysis and uh, digital electronics, that's when I actually had an interest in learning this stuff. The reason was because my first semester was just too heavy for me, but then second and third semester I managed to go ahead with that. So it depends on person to person. At one point, you might like FPGA, and then at another point, you might like circuit design. So yeah, just see what it honestly depends on what you like to see happening. You want to see D flip-flop working, or you want to see an op amp doing something. So yeah,
Thank you, sir.
yeah, yeah.
Okay, do we have any other questions? All right, I suppose the questions are being resolved by Mr. Dinesh Panikar. And
Hmm.
I'm definitely thankful to Dinesh Panikar for sparing his time and giving such an insightful session. I'm sure there was quite, lot many things that the students could clear their doubts, and they have got idea about how to proceed from EC towards embedded and as good as getting, I mean, going to Germany or what all things are needed for it. So really, thank you so much, Dinesh, for sparing your
Yeah.
time, and I really loved your session. I hope that the students who are present here in the session were being attentive and they have got some knowledge about or have got their doubts cleared about this domain as well. Okay. And I look forward to having your sessions ahead for
Sure.
the other batches and even these students, if they at all have any queries, I think so they, if they wish, can get connected with you?
Yeah, you can connect with me on LinkedIn. I could share my
Yeah.
LinkedIn profile in the chat. You can connect
Yes,
with me
yes.
on that. And
Ye-
uh, this is my. I would share three things actually: my LinkedIn and my GitHub and
Okay.
GitLab. GitHub. This and this is my GitLab. Uh, the reason I have a GitLab is because I was looking at some. There's a thing called a GSOC, Google Summer of Code,
Mhm.
and they had some things on Kimu. So that's the reason I have a GitLab account as well. Just wanted to see what all problem statements they had there. So yeah, you can connect with me on any of these three platforms.
Okay, that's great.
Yeah,
Much, Dinesh, for sparing your time and giving your guidance. Okay, we'll be in touch with you and
sure.
hoping for a few more such sessions with you. I'll talk to
Yeah.
you about this. Okay, so thank you. Thank you, students,
Okay.
for joining the session. Yeah, thank you. Have a great time. Thank you.
Yeah. Thank you guys. Ciao, ciao.
Good day. Bye.